Working in risky, drought-prone environments in the semi-arid tropics and extending technology to reap the maximum benefits in such hostile conditions has been the primary objective and mission of the International Crops Research Institute for the Semi-Arid Tropics, or ICRISAT. The overarching goal of ICRISAT is people-oriented and partnership-based research, contributing to improved food security, livelihood resilience, and poverty reduction, while protecting the environment of the production systems in the semi-arid tropics. In the mid-80s, there was an urgent need to enhance groundnut production and yield to meet the rising demand in the country.
This rising import bill of the edible oil was a major concern to the government of India. It was the second largest import bill after the petroleum products at that time. To tackle this problem in a holistic manner, the government of India established a technology mission on oilseed, empowering it to address all the issues related to production all the way to marketing and import. The groundnut productivity at that time was very low, around 800 kg per hectare.
The Government of India's Oilseed Technology Mission in 1986 was the impetus for the groundnut production technology at ICRISAT, brought together with other partners in the same field. The International Fund for Agricultural Development provided strong and timely support for the project.
The Ministry of Agriculture, Government of India, was aware of the high groundnut yields obtained at ICRISAT. They invited ICRISAT to demonstrate the potential of improved groundnut technology at farmers' fields. Responding to this request, ICRISAT put together a team of multidisciplinary scientists and created in 1987 a new unit, LEG-OFTEN, Legumes On-Farm Testing in Nursery, to carry out the task. Once it attracted the attention of central government, then Ministry of Agriculture, ICAR, state government, state departments of agriculture, then Growers Federation, everybody became interested, including National Dairy Development Board, and they really wanted to take this technology in a big way to the farmers in all over the country.
Then we established a procedure how to go about it. What we did, we had a meeting with the scientists of the NARS and also State Department of Agriculture, and established first the fact where there is a need for taking the technology.
8 Indian states were identified after carefully reviewing available relevant research information and identifying production constraints. A unique package was suggested for each location after characterizing soil, climate, nutrients, water, pests, and diseases. Spearheading this initiative was a team from ICRISAT. They had done pioneering work in Parbhani, Amravati, Nanded, Yavatmal, and other districts and villages in Maharashtra, the heartland of the Indian semi-arid tropics. Umra is one such village where the benefit of the spread of the ICRISAT groundnut production technology was most prominent. Malnourished children and hungry mouths invited ICRISAT team when they first set foot in the village. Sore with abject poverty and parched lands, Umra sighed for a helping hand.
नाजूक होती, कोरडवाहू शेती सर्व लोक साधारण कोरडवाहू शेती करत होते आणि कापूस, ज्वारी, Earlier, farmers of Umra village were into traditional farming. Most of the farmers were growing one crop in a year under non-irrigated conditions. They used to grow mostly cotton, sorghum, pigeon pea and groundnut. Yields were very low. Farmers were in debt from money lenders.
We did not get jobs in the village. Both men and women used to go to other villages in search of work. We got very low wages, just 10 rupees per day. We used to keep our older children at home to take care of the younger siblings instead of sending them to school. We used to eat sorghum, roti and dal and very rarely vegetables.
The groundnut production technology was tailor-made for villages like Umra. The groundnut production technology, or GPT, comprised of 5 components. Soil is prepared for raised bed and furrows by opening furrows. This specific land preparation system is known as broad bed and furrow, or BBF. Years of continuous farming leads to depletion of soil fertility. Based on the soil types, effective application of macro and micronutrients were recommended for a better yield. Improved high-yielding variety seeds like ICGS 11, ICGS 44, ICGS 76, ICGS 21 seed rate and seed treating were developed by our scientists at ICRISAT for this technology. Water is scarce in the semi-arid tropics. Water use efficiency increases with the use of furrows compared to conventional flooding on flat land. Sprinkler irrigation was recommended to improve the efficiency further. Need-based application of insecticides and pesticides was recommended for control of insects, pests and diseases. Adoption of the technology was not an easy task for the people of Umra. Most of the farmers were small, marginal and medium landholding farmers in acute poverty. Options were shrinking with frequent crop failures, out-migration of labor, and families incurred debts and sold off their assets to make ends meet.
The scientists from ICRISAT conducted a meeting in the State Bank of India premises at Mahur and asked us as to who was willing to adopt this technology. Baburao Deshmukh and a few others volunteered to adopt it. Mr. Bawase, an officer with SBI, came forward to assist the villagers financially. Later we came to the village from Mahur and formed a group of 25 farmers. We unanimously elected Baburao Deshmukh as the president and Digambar Gire as the vice president. Later all of us went to Newali village of Parbhani district to see the demonstration of the ICRISAT technology on the fields. We discussed about the problems and benefits from the technology and decided to work together for the adoption of the technology.
Under Baburao Deshmukh's leadership, the Krishi Vikas Mandal was formed.
नवीन तंत्रज्ञान तर घ्यायचं सुद्धा आम्हाला याचं एक तर तंत्रज्ञानाविषयी लागणारे अवजार काही
We observed that this technology needs more finance to buy implements, additional inputs and labor. We decided to cooperate with each other and form a mandal. Through this mandal, we purchased a bed marker, inputs and improved seeds. We found that cooperation among farmers and laborers is a must for adopting the technology.
The stimulus of propagating the groundnut production technology compelled a collective action, and the villagers volunteered for better livelihoods. Research data collected by our scientists revealed that adoption of components varied from 35 to 100%. The farmers were primarily interested in ICRISAT seed, but later, for maximum productivity, they adopted the other components as well. Most individuals couldn't adopt the technology by themselves, as dealers were not willing to provide inputs on credit, and it was too expensive for individuals to purchase tools and other inputs.
बँक अगोदर आम्हाला अपुरं कर्ज देत होती, तर त्याच्यामुळे ते काय पुरत नव्हतं.
Earlier, farmers were not getting enough loans from banks. They took loans from money lenders, and it was difficult for them to repay in time. Interest rates were high. Now, they are getting enough loans from banks.
तेव्हापासून आमच्या गावाची परिस्थिती सुधारली.
The high adoption of technology was a result of developing and using various kinds of social networks and resources. It is about realizing and understanding how poor farmers and the farming community can benefit from improved agricultural technologies with the help of these networks. What emerged was build-up of social capital.
Social capital led to collective action that facilitated groundnut production technology adoption in Umrah. By the build-up of social capital, we mean the ability and willingness to form social networks and the ability to form relationships of trust. In this particular case, social capital led to sharing of information. It provided access to all kinds of tools and inputs, and in many different ways, it facilitated the adoption of groundnut production technology in this village.
तर ते असे आहेत, याच्यापैकी एक जिप्सम हे एक खत आहे, हे भुईमुगाला आवश्यक होतं.
Our soils were poor in calcium, so gypsum use was recommended in this technology. Earlier, gypsum was not available in the market, so we collected the required money from members and sent 2 farmers to Mumbai and brought a truckload of gypsum from Rashtriya Chemical and Fertilizers and distributed it amongst ourselves. Later, the government of Maharashtra started providing gypsum on subsidy. But initially, it was difficult for individual farmers to get gypsum. We got it only as a group.
शासनाने याच्यावर विचार करून आता आम्हाला शासनातर्फे जिप्सम मिळते.
A remarkable feature of these changes that swept through Umrah was that the centuries-old caste and class distinctions were shattered with the build-up of social capital. The build-up of social capital mediated adoption of groundnut production technology. People understood the importance of collective action. Adoption was widespread, and the benefits were substantial and conspicuous. These included higher yields and incomes, better nutrition and food security, ownership of assets, employment generation, out-migration was replaced with in-migration, and the community emerged out of poverty.
मजुरी करत करत पैसे आम्ही काही दिवसानं मजुरी करत करत पैसा थोडाफार जमा झाला. पैसा जमा झाल्यानंतर आम्ही
Earlier, I did not have land and worked as labor on others' farms. We did not get enough food to eat. Later, we used to cultivate others' lands on lease, and we saved some money. Along with other farmers in the village, I also started cultivation of groundnut by using the ICRISAT method. Our farm income increased slowly, so I purchased land. Now we earn more profit from farming. We have enough food to eat with quality and variety, and also have enough produce to sell in the market.
Reduced poverty was accompanied by increased food security in Umrah due to increased employment and income throughout the year. The landless labourer earlier had only jawar and dal. Now They also have wheat and vegetables.
Because of GPT, our crop yield increased. This led to increase in income. Cropping pattern changed from one crop to 3 crops in a year, and crops changed from cotton and sorghum to soybeans, chickpeas, groundnut and vegetables. We renovated our houses. Our village looked improved, and people purchased vehicles, televisions, fridges and other amenities. Our status improved in the community. Now you can see the difference between BBF groundnut and non-BBF groundnut. The groundnut crop on BBF has more pods, is fully developed and has more nodules. So our soil health has improved. This development was possible because of adoption of GPT. Now farmers from surrounding villages are also adopting our technology.
The medium land holding farmers' food platter had more variety and their basic amenities improved. Credit access, health and sanitation facilities, investment in children's education, and every sphere of life improved in dynamic proportions.
Because of increase in income, the farmers were able to pay back the loans in time. By 1992, our whole village was loan free. All farmers repaid their loans.
Insatiated with their achievements, and under the leadership of Baburao Deshmukh, they explored, experimented and chanced upon innovative methods in groundnut production, and adopted the components of GPT for other crops as well. Dependability on ICRISAT for seeds gradually phased out. Farmers now use improved TAG24 or TG26 varieties, as this fit into their crop patterns in terms of crop duration. However, they still prefer ICRISAT varieties.
सुरुवातीला आम्ही भुईमुगाच्या जाती ICRISATच्या ICGS 44, ICGS 11.
In 1989, we got ICRISAT groundnut cultivars like ICGS 11, ICGS 76 and ICGS 44. We grew this for 4 to 5 years. We got more yield compared to the local varieties. Now we are growing TAG24 and TG26, which are of short duration but are disease prone. We would be happy if ICRISAT provides more cultivars of groundnut, chickpea and pigeon pea suitable for our village.
The farmers started experimenting with the GPT package. They started sowing 5 rows, 3 rows or 2 rows, enhancing the BBF concept, which was modified to suit the requirements of the farmers into narrow bed and furrow with a bed of 75 centimeters and ridge and furrow systems. The dibbling method of sowing is tedious, time-consuming and back-breaking for women, though it provided them additional employment. The men and women farmers came together to solve these problems. The result was an improved seed drill machine that efficiently replaced the manual dibbling method, saving the women drudgery and time for other employment. More employment meant more income for them. Vishal Gidhe, a young and enthusiastic farmer, developed a hoe for weeding, a fine example to save drudgery for women. Women particularly gained significantly in many ways due to the adoption of GPT. The role of women in groundnut cultivation gave it a status of women's crop. The farmers generated good quality seed material from their crop by selection and segregation for reuse or sale. This activity generated more employment for women for the shelling of groundnut pods. The underprivileged class, especially women, not only gained higher wages and year-round employment, but are also acquiring political strength and a voice in decision-making. Now, women not only make domestic decisions, but have a balanced say on the farm activities as well. Our study also revealed households where decisions are exclusively taken by women. Financial independence enabled women to join self-help groups and form informal networks through puja groups, mutual finance groups and Mahila Mandals.
I became a key member in the decision-making process of the family. I have 10 to 15 women labor working under me. I observed that though they earn more now compared to what they used to, they do not have the habit of saving. When they need money, they go to the money lenders or sell off some asset. So I explained to them the importance of saving and asked them to save at least one day's wage in a week. I took the lead and asked them to form a group. I arranged meetings every week and collected one day's wage from each member. They have realized the importance of this group and have continued this way.
More women were going to Kisan Melas as a part of women's groups. This mini revolution took place with encouragement from the male members in the family. The focus group meetings revealed that women gained more confidence and had a voice in the village compared to what they had prior to the introduction of the technology, giving rise to gender equity. Though networks empower women and help build and maintain social capital, the characteristics of individuals also play a role. Ramabai, who comes from a Dalit family, is a medium landholding farmer, runs a vocational training center, and leads a mutual finance group. She has the capability to volunteer for positions in other informal groups. She performs well in all leadership positions and participates actively in collective decision-making. Including women in the decision-making of the family, the community, and the village at large led to their empowerment. The changes in Umra can be better understood if we compare it with Ashta, a neighboring village. Lack of collective action was found to be the main constraint for adoption. The village has a considerable number of large landholding farmers who lack the realization of cooperative and collective action for the upliftment of small landholding farmers and landless laborers. Social capital requires leadership. While efficient leadership steered a revolution in Umra, Ashta had too many leaders, and reaching a consensus was a mighty task. Class distinctions in Ashta were too wide to bridge.
The potential benefits of GPT as seen in Umra could not be achieved here due to lack of cooperation, collective action and leadership.
Women were less empowered in Ashta. The women of Ashta had little or no say in decision-making. Most of the female-headed households belonged to the labor class and had low incomes. Since they lacked year-round employment, food insecurity prevailed. We set out with an initiative for developing and exchanging technology. But while forging ahead with our mission of science with a human face, we realized in the process that social capital and gender equity played a significant role in the success of the project. Women have always played an important role in agricultural activities. Now, with technological support, they are able to reap the benefits together with men. This project has unveiled hidden results and lessons to our ongoing learning process. What started as our mission for enhancing productivity and poverty alleviation is today our vision towards women's empowerment as well. Umrah is just a beginning.